Now we're going to talk about another creational pattern, the factory method pattern. Along the way, we will also learn about a factory object. Just like a factory in the real world, the purpose of these factories in object-oriented programming is to create objects. Using factories makes your software easier to maintain and change, because object creation happens in the factories. The methods that use these factories can focus on other behavior. Imagine that your software implements an online store, and that you want to create objects to sell in that store. Let's use a knife store, for example. There are many different types of knives, but let's start with steak knives and chef's knives. You have a superclass, knife, with subclasses steak knife and chef's knife. You write a method to order a knife, which will first create one of these knife objects and then prepare it for shipment. Let's say that the preparations that it performs on the knife are sharpen, polish, and package. Your method looks like this. The method first declares a knife variable, which will refer to the knife object to be created. The conditionals determine which subclass of knife is actually instantiated. The act of actually instantiating a class to create an object of a specific type is called concrete instantiation. In Java, you usually do concrete instantiation with the new operator. You will soon see that concrete instantiation will be the primary purpose for our factories. The next step is to call some methods that are common to the different types of knife objects: sharpen, polish, and package. These methods do not care what type of knife is created. All they want is a knife to operate on. Imagine that your store adds more and more knife types as its sales improve. New subclasses are added as needed: bread knife, paring knife, etc. In this example, the list of conditionals grows and grows as new knife types are added. Notice that what we do with the knife after creating it doesn't change. All of these knives need to be sharpened, polished, and packaged. This is all getting pretty complicated. What if instead of making your knives in the store, you could make them somewhere else? Just as in the real world, objects are usually made in factories. We can create a factory object whose role is to create product objects of particular types. So the sharpening, polishing, and packaging will stay where it is in the order knife method, but you will delegate the responsibility of product object creation to another object, a knife factory. You're going to move the code for deciding which type of knife to create, and the code for deciding which subclass of knife to instantiate, into the class for this factory. The class for a knife factory is shown here, with a createKnife method. Some other code will instantiate a knife factory object, but once done, you can use the createKnife method to make knife objects of particular types. This is almost the exact same code used to create a knife object in the previous example. It has just been moved into a method of a new class called a knife factory. In general, a factory object is an instance of such a class, which has a method to create product objects. Now, this knife factory can be used by the knife store class. In other words, the knife store is now a client of the knife factory. Look at this example. In this example, the knife factory object to use is passed into the constructor for the knife store class. The order knife method is very similar to before. However, instead of performing concrete instantiation itself, it delegates this task to the factory object. What have you gained? First of all, the knife store and its order knife method may not be the only client of your knife factory. Other clients may use knife factories to create knives for other purposes. Maybe there's a method for bulk orders or quality testing. Since all of the actual knife creation happens in the knife factory, you can simply add new knife types to your knife factory without modifying the client code. If there are multiple clients that want to instantiate the same set of classes, then by using a factory object, you have cut out redundant code and made the software easier to modify. Instead of hunting down multiple snippets of similar instantiation code, you can simply add or remove the particular subclasses to instantiate in your factory. If you change the way that subclasses are instantiated, you only need to change your factory, rather than every client. Look at the order knife method. As far as it's concerned, as long as it receives a knife object from the factory, it can satisfy its responsibilities. This allows the developer to make changes to the concrete instantiation without touching the client method. The client method does not need to name concrete knife classes and now deals with a knife generalization. This is called coding to an interface, not an implementation. Think of this like a real-life factory. Usually, when a store is selling something, like the knife in our example, the store itself does not make that item. Instead, the store gets their knives from a knife factory. This knife factory makes knives for the store, but may also have other clients, such as other stores that need knives. If the factory changes the way it makes knives, then the stores don't care, as long as they receive knives of the right type. Perhaps the blade material changes, or the handles change shape. These changes are made in the factory, not in the store. Okay, so we can use a factory object to instantiate product objects. Although it is a useful technique, the factory object is not actually one of the Gang of 4 design patterns. Let's take a look at the factory method pattern. The factory method pattern approaches the creation of specific types of objects in a different way. Instead of using a separate object, a factory object, to create the objects, the factory method uses a separate method in the same class to create the objects. You're going to see that the power of the factory method comes from the way it creates specific knife products. To create specialized product objects, a factory object approach would subclass the factory class. For example, a subclass of our knife factory called Budget Knife Factory could create Budget Chef's Knife and Budget Steak Knife product objects. A Quality Knife Factory could create Quality Chef's Knife product objects or Quality Steak Knife product objects. A factory method approach instead has a Budget Knife Store subclass of Knife Store. The Budget Knife Store has a method, the factory method, that is responsible for creating Budget Chef's Knife and Budget Steak Knife product objects instead. The factory method design intent is to define an interface for creating objects, but let the subclasses decide which class to instantiate. What does this look like? Let's look at the Knife Store superclass first. First of all, Knife Store is now abstract. This means we cannot instantiate a Knife Store. Instead, you will need to have Knife Store subclasses, such as Budget Knife Store or Quality Knife Store. These subclasses will inherit the same order knife method. Just like before, the order knife method uses a factory, but now it is a factory method. The factory method in this example is createKnife. It is declared in the superclass, but it's abstract and empty. We left the factory method empty and called it abstract because we want the factory method to be defined by the subclasses. Whenever a Knife Store subclass is defined, it must define this createKnife method. Let's take a look at what a Knife Store subclass looks like. Now you would instantiate a Budget Knife Store. The Budget Knife Store has its own method for creating knife objects. A different knife store, such as Quality Knife Store, would have a different factory method. You can't define a new Knife Store subclass without providing this method. Because the Budget Knife Store is a subclass of Knife Store, it inherits the order knife method. You run the common order knife method from any subclass of Knife Store. All the subclasses of Knife Store, Budget Knife Store, Quality Knife Store, maybe Family Knife Store, inherit the order knife method. However, each subclass must define its own createKnife method. Let's take a look at the UML class diagram for one Knife Store. The UML class diagram gives you some important information. First of all, both Knife and Knife Store are italicized to denote abstract classes. You cannot instantiate these classes directly. You must define subclasses of them. The UML diagram shows only one subclass of knife, but there could be more. Budget Chef's Knife, Budget Paring Knife, etc. We could also have more than one Knife Store, maybe Quality Knife Store or Family Knife Store, which would make other types of knives. The createKnife method is also abstract in Knife Store. This means that any subclass of Knife Store must define this method. So, Budget Knife Store and any other Knife Store subclass we define must have its own createKnife method. This is the core of the factory method design pattern. The factory method pattern always follows the same general structure. Let's check out the UML class diagram. We have an abstract creator class. This class contains methods that only operate on generalizations. In other words, as long as we give these methods the products they want to operate on, they're happy. In our example, the product was knife. The creator also declares the factory method abstractly, so that each concrete creator class is obliged to provide a factory method. The concrete creator is a subclass of the abstract creator. We call it a concrete creator because it is responsible for concrete instantiation, the actual act of creating objects. The concrete creator also inherits methods from the abstract creator. Factory method is a method in our concrete creator subclass. Every time the developer adds a concrete creator subclass to the design, they must define a factory method to make the right products. This is how the subclass decides how to create objects. The product superclass, which was knife in our example, generalizes the concrete products. As far as the creator class is concerned, its methods only operate on the general product, never the concrete products. The concrete products are made by the concrete creator. The type of product made is decided by which concrete creator is made. In our example, the Budget Knife Store made Budget Chef's Knife and Budget Steak Knife, while the Quality Knife Store could make Quality Chef's Knife or Quality Steak Knife. In this lesson, we covered the factory method design pattern and factory object. A factory is generally a method or object that allows you to create other objects. Remember that the act of object creation, usually with the new keyword in Java, is called concrete instantiation. Factories allow client code to operate on generalizations. This is called coding to an interface, not an implementation. As long as the client code receives the object it expects, a knife in our example, it can satisfy its responsibilities without worrying about the details of object creation. A factory object may be a useful tool. It is an object that creates other objects. It could be useful if many parts of the software want to create the same objects. You can even create specialized factories by having subclasses of the factory class. The factory method pattern is a little bit different. Instead of using another object to create objects, we separate out object creation into another method, a factory method. Now, instead of working with the factory object, we specialize or subclass the class that uses the factory method. Each subclass must define its own factory method. We say that we are letting the subclasses decide how objects are made. By separating the actual object creation from other behavior using factories, the code becomes cleaner to read and easier to maintain or change. The client code is simplified, and the details of object creation are moved into the factories. The code becomes more extensible and harnesses the power of object-oriented design principles, such as inheritance, to allow you to specialize your object creation.